Hello students, this is the lesson for the 4-1 notes on 3-step stoichiometry part 2. So for your starting today, just go ahead and take a look at this image and think to yourself, which of these steps need to happen for this question? So the question is, how many grams of hydrochloric acid are needed to produce 65 grams of lead chloride? So pause the video for a moment, think to yourself, what is the number that I know, its units, and the chemical? That's what we're going to start with. All right, so taking a look here, you should be able to see pretty clearly here that we're starting off with 65 as our number, and units for this are going to be grams, and the chemical is lead chloride. So this right here is what we would call our start. So we're going to go ahead and put this over on the left-hand side. So PbCl2 will be our pink side here. And it does say that we're starting off with grams, and so grams would be our mass. So that's what we're going to start with over here. Now think to yourself, what are we actually solving for? Look for the question words of how many. Okay, so taking a look here, it specifically says how many grams of hydrochloric acid. So this hydrochloric acid is a different chemical. This is going to be our end. And so we need to go ahead and label the other side over here as hydrochloric acid, HCl. And again, this time we're ending with still grams here, but just of a different chemical. So grams means that I need to be looking at mass. Now go ahead, pause the video, and think to yourself, what would be the middle steps? All right, so taking a look here, in order to get from mass of the first chemical to mass of the final chemical, we need to stop over in the magic mole ratio, moles to moles. So we need to first get moles of our original chemical and then moles of our final chemical. All right, so we have step 1, step 2, 3, and 4. All right, so we're going to use this entire roadmap for this type of question. All right, so again, taking a look here, we start off with our lead chloride, start off with our mass. We're ending with our hydrochloric acid, ending with mass. And again, we need these middle steps. You can never go straight from mass to mass. You have to first go 2 moles, and then you can convert to different moles. All right, so there are only 11 days left of the trimester and then, or of the school year, and then courses are over and no work will be accepted after that final deadline. Today we're taking a look at the 4i notes along with this 4i recording. Again, school is ending very soon, so please make sure that you are catching up on any work. We only have a few more lessons left, so we'll be taking a look at Unit 5 lessons, and then the week after this we will have our final exam. So taking a look here, we're at the last lesson of unit number 4. Again, we're going to be going straight into unit number 5. So again, we did update our schedule. This week you do have STAR 360. This is worth 5% of your overall grade in every class. So that's, even though it's a reading and math exam, again, you still get credit in all your other classes as well. So science, English, history, PE, tech, etc., etc. So what that means for you is it's a good way to boost your grade in every class. So make sure that you take your STAR 360 assessments, especially if you are behind in your grades. Taking a look here, you will have reading tomorrow on Tuesday during whatever your normal period 2 classes, and you will have math on Wednesday during whatever your normal period 3 classes. Keep in mind that you are still responsible for completing the same lesson as everybody else. You'll just do it through the recording. So if you finish the exam early, you can go ahead and get to work on your notes using the recording, or you can always do it in the afternoon as well after live classes are over. It should be, the exam should not take you more than 20-30 minutes, and again, the lesson should be pretty short as well, so make sure that you are getting that done. Originally, we did have an exam scheduled for the same day as this reading exam, so we did alter the schedule to make things a little bit more manageable. So taking a look here, we are again right here at 4i. We're going straight into Unit 5, and then next week we will have the combined exam, Units 4 and 5, on Wednesday, June 2nd. That's when it's due. It won't be zeroed out until Thursday though, so you do have a bit of a grace period. And then you'll have a week to make up any last minute missing stuff, focusing on projects, Unit 1, 2, and 3, and then obviously that last exam. Altogether, they're worth 70% of your grade, which means it's impossible to pass without doing projects in the exam. Keep in mind the last day of school is Wednesday, June 19th, and courses close at 11:59 p.m. And then you will no longer be able to access your course, submit anything. There are no extensions. This is a hard deadline. Again, it's the end of the school year. We have a very quick turnaround for grades, especially for graduates, so there will be no extensions. At this point, I am on maternity leave, so if you are on my roster, currently the plan is that your substitute is now Ms. Smith. So if you need help with anything in the course, definitely contact her. However, if you do need help on the projects, because Mr. Bangle has been with us the entire time and has more of a science background, please make sure to actually contact Mr. Bangle, just because he's a little bit more familiar with what's going on with projects. So taking a look here, here's his phone and email. Make sure if you need individual tutoring that you contact him. He doesn't really have office hours, so make sure that you actually reach out to him and communicate with him if you do need a time for tutoring. So our objectives for today are to identify the correct steps needed to complete a problem using the MOL roadmap and specifically complete 3-step Stoic problems. Again, we have been doing 3-step Stoic problems, so we'll just be finishing that up. Again, getting a little bit more practice in our last lesson. So at this point, if you haven't already, please make sure that you open up your 4i notes and then click Start Quiz, pause the video, and then continue playing when you're ready. All right, so let's go ahead and do a quick brainstorm to kind of refresh our memories here. So the question is, what are the 2 possible mole ratios for iron and iron oxide? So iron Fe, iron oxide Fe2O3. You can see a balanced chemical equation here. So go ahead, pause the video, think to yourself, what would be the 2 possible mole ratios here? Again, you should be looking at coefficients. Coefficients tell you how many moles are in a balanced chemical equation. All right, perfect. So taking a look here, if we are taking a look at iron on top here, then I would look at its coefficient right here, which is the number 4, and so I would plug that in right here. So 4 moles of iron for every blank moles of iron oxide. Here's iron oxide in my equation, and you can see its big coefficient right in front here is a 2. So there's 4 moles of iron for every 2 moles of iron oxide. All right, again, this is if we are solving for iron on the top. Okay, that's what we put if we're solving for something on the top. However, if I want to instead go from iron to iron oxide, then I would need to flip this, right? So if I want to solve for iron oxide, which is just rust, right, then that one needs to go on top. And I would just flip these numbers as well. So still making sure that the 2 goes with iron oxide because that's what I have in my equation. And the 4 goes with iron because that's what I have in my equation up here. Okay. All right, over here we have the next question. What 2 possible conversion ratios using molar mass of iron oxide are there? Right, so what we're going to go ahead and take a look at that. So the molar mass of iron oxide is 159.69 grams per mole of iron oxide. So we're going to go ahead and remember that anytime we have a division signs are just fractions in disguise. So you can kind of see right here, I have that same division sign, just now in fraction form. So one of these things needs to go on top, the other thing needs to go on the bottom. So let's go ahead and start off with grams. We need to figure out what number is next to grams and then what number is next to moles. Go ahead, pause the video for a moment and think to yourself what would be the correct answers here. All right, so let's go ahead and take a look here. So if I am taking a look at grams right here on top, well, I need to look for grams in my molar mass and find the number next to it. And the number next to it is 159. So 159.69 grams on the top here. And then looking for moles, right? Moles of iron oxide is the bottom part of my fraction here. Taking a look at the number next to it, it's a blank, and remember that blanks just mean 1. Because anytime we say grams per something or anything per something, it's always per one of those things. So grams per 1 mole. So I'm going to go ahead and fill in a 1 right there. Okay, so again, taking a look at this, taking a look at this, we are specifically solving for grams on top, right? So solving for grams from moles, right? So we're going from moles to grams. But again, if I want to instead go from grams to moles on the bottom, then in this case, I would need to put moles on the top. But again, the same numbers need to go with their units. So 1 still goes with moles because again, we still have a blank or a 1 next to moles in our molar mass. And 159.69 still needs to go next to grams because we have that next to grams in our molar mass. All right, so taking a look here, let's go ahead and look at our responses here. So these are the two possible answers for question number 2. Make sure you have both answers. So 4/2 and 2/4 with those correct units. And then same thing over here for number 3. Make sure that you have a fraction checked off with 159.69 over 1. Right, grams and moles will be matched up with those. And over here, the reverse, 1 over 159.69. Again, making sure that those units are correct. Pause the video, continue playing when you're ready. Okay, so let's review the mole roadmap right here. Again, we've seen this several times throughout the past few lessons. So remember that when we're talking about the same chemical, we can use molar mass to convert between grams and moles. So you'll notice, right, that we can see molar mass down here for the pink side and molar mass down here for the blue side, but they have to stay on their side, right? So if I want to go grams to moles or moles to grams, again, I need to use molar mass, but it's still going to be the same chemical. No matter what, this will be the same chemical. In this case, our starting one, and over here as well, this will also be the same chemical, but in this case, our ending chemical. Now, the only way to get from the starting to the ending chemical is to use our magic mole ratio. So we can only convert to different chemicals if we use the mole to mole ratio that we get from the balanced chemical equation. Remember that we often give you the balanced chemical equation in class just because we don't have a lot of time in class, but that you will need to know how to balance chemical equations for your last exam. Okay, so again, this is the most important part of our magic of our mole roadmap here. Everything needs to basically get to moles. So whenever we're doing stoichiometry, essentially we're trying to get to moles, and then once we get to moles of our starting chemical, we can then go to moles of our new chemical. So if you have two chemicals involved in a problem, you need to always get to moles. Moles to moles is the most important part here. This is going to be the answer to number 4. Go ahead and pause the video and fill in the blank with the word convert. Go ahead and take a few moments to do that and then continue playing when you're ready. Okay, so let's go ahead and practice a problem. Remember that we will practice one problem together, and then the last one you need to complete on your own. So how many grams of iron oxide can be formed if you have 90 grams of iron? For now, we're going to go ahead and ignore what is in the parentheses. So pause the video, think to yourself, what are we starting with? I need a number, unit, and chemical. Okay, so taking a look here, you should have identified that your number that you have is 90, so this will be our known. That's what we're going to be starting with up here is 90, our known, okay? And the units here, again, are grams, and the chemical here is iron. So I'm going to go ahead and, again, label this as my start. So down here in my mole roadmap, the iron will be my starting chemical that I'm putting here in pink, okay? And again, we're starting off with grams here, so I should be circling mass. That's what we're starting with. Now go ahead, pause the video and think to yourself, what are we ending with? Look for the words how many. Okay, so taking a look here, you can see the words how many, and it says grams of iron oxide. So iron oxide is a new chemical or a different chemical. This is going to be our end. So I do need to label the other side of my roadmap now with this new chemical, so Fe2O3. Again, if I was staying at the same chemical, then I would stay on the pink side, but because this is a new chemical, I do need to move over to the blue side. Again, it is asking specifically for grams, so I'm going to go ahead and circle the mass of our roadmap over here. Now, thinking to ourselves, we should be able to figure out what the middle steps are. So the middle steps here are definitely going to be, again, moles to moles. You cannot just skip over to your mass because you first need to get to moles. So first you need to get moles of the same chemical, and then finally moles of our next chemical. Okay, so this is going to be kind of our first step, second, well, our first fraction, our second step, which is really our first step, then 3, then 4. All right, so let's go ahead and fill this out. So we're going to start off with what we know all the way over here on the left, which is the grams of iron. So we knew that we had 90 grams of Fe. I want to turn this into a fraction, so think to yourself, what should I put this over? Yep, I should go ahead and put this over 1 because anything divided by 1 is still itself. Now, in the next step, I want to get rid of grams of iron. So think to yourself, where should it go? Right, it needs to go on the opposite side, which would be the bottom here. Remember that anytime we have something on the top and the bottom of a fraction, it actually just divides out and equals 1. And so 1s we can leave blank, right? If you think about 3 divided by 3, that just cancels out to 1, and so we can just get rid of it. So that's exactly what's happening with our units here as well. Okay? All right, so I have grams of iron on the bottom, and now we need to think about what do we need to solve for on top. Again, I need to first get to a specific type of units in the same chemical. So think to yourself, what should go on top? Both the new units, but the same chemical. Well, the chemical is iron, so it still has to be iron, obviously, but we're going to go ahead and again get to this magic part of our roadmap, which is we need to get to moles of iron. Again, I cannot yet get to a new chemical because I was not yet in moles, I was in grams. All right, so here we go, we've got moles of iron on top. Now, what we need to go ahead and think about is we need something that is always standardized or true, that has both moles and grams, specifically of iron. So taking a look here, we have a couple things here that are standardized things. So I'm going to go ahead and box them up here, right? So we have the molar mass of iron oxide, we have the molar mass of iron, and we have the chemical equation right here. So we need to think about which of these three things has moles and grams and is specifically for iron. Pause the video and think to yourself, which of these would I use? All right, so taking a look here, the only thing that has both moles and grams is our molar masses, but specifically we need the one for iron, so it's going to be the second one right here. So then let's go ahead and take a look at what that looks like. So I'm going to go ahead and point down here, so we're going to be using this. All right, so think about what goes next to moles. We already kind of did a practice of this. Again, next to moles is a blank, and so blanks mean, yeah, they mean 1. So that should go on top here, next to moles. And then we need to figure out what needs to go next to grams on bottom. Pause the video, think to yourself, what should go next to grams on the bottom? Well, if we take a look here, here's grams in my molar mass, and right there I have 55.85. So 55.85 should go right here, next to grams on the bottom. Now I do want to point out that this is really important. Again, we do have to be getting it from the molar mass because the molar mass is always true. Okay, you would not get it from the actual problem because you won't always have 90 grams of iron in a problem. So that's not always true. However, we do know that the molar mass of iron is always true. So again, we always need to use something that is true. I'm going to go ahead and erase this because now that we've used it, we don't need it again. All right, so at this point, we've gotten rid of our grams of iron, and we are now at moles of iron. So I want to get rid of moles of iron. Where does it need to go in the next step to get rid of it? Think about that to yourself. Yeah, I would need to go on the bottom, so moles of iron goes on the bottom to get rid of it, divide it out, cancel it out. And on top, now that I'm in moles, I should be able to switch to the same units, moles, but for the new chemical. Again, now we can go moles to our new chemical. Pause the video and think about what units should now go on top. Well, we're right here at step number 3, so we've got our chemical iron oxide, and again, it's moles to moles, so we still need moles, but now of Fe2O3, that's going to go ahead and go on top here. Let me go ahead and make that a little bit more condensed. Cool. All right, so let's go ahead and think about where we can see moles and moles. Again, anytime we do conversion ratios after the starting step, everything else needs to be stuff that's always true, right? So in this case, we need something that's always true that has moles and moles moles of iron oxide and moles of iron, no grams. So think to yourself, which of these two remaining things has moles of iron oxide and moles of iron with no grams? Well, up here we have iron oxide's molar mass, but that definitely has grams inside of it. It also has nothing to do with iron, so we need to look down here, and the correct answer is we should be taking a look at our balanced chemical equation. Again, we need something that's always true. Balanced chemical equation will always be true. So iron oxide and iron are both in here. There's no grams, it's just moles. Those coefficients are moles. So let's think about what needs to go next to the moles of iron oxide on the top. Well, let's take a look here at iron oxide. Think to yourself, what is the coefficient here, and therefore what is the moles of iron oxide? Well, our coefficient right here is the big number in front, which is the number 2. So the number 2 should go on top here. And same thing, think to yourself, what should go next to moles from our balanced chemical equation? So here's our iron, moles of iron. Think about that. Well, its coefficient or big number is a 4, and so that should go on the bottom next to our moles of iron. All right, so at this point, we figure that out. We can get rid of that one because we've used it. And let's go ahead and check our units here. So we got rid of moles of iron. I'm currently at moles of iron oxide. Think to yourself, is that what I'm supposed to be solving for? Remember the question words, how many blank of blank? Currently I'm at moles of iron oxide. Is that what I'm supposed to be solving for over here? No, I am not yet to the answer. I have moles of iron oxide, whereas the question's actually asking for grams of iron oxide. So I need to keep on going to my last step right here, right? So the last step is that we are now in the same chemical, our ending chemical, moles of iron oxide, goes on the bottom to get rid of it. But now to solve what my final answer, I can now go to new units. So again, now we're on the blue side. I need to stay on the blue side, so same chemical, but now I can do new units for that chemical, so grams now of iron oxide. Okay, so thinking about all of this stuff that we have standardized and true, what has both grams and moles, specifically for iron oxide, there's only one option left, but still think to yourself, does that make sense? Yeah, so taking a look here, we can see that absolutely, I can see in here that I have grams and moles, and this is for iron oxide, and this is always true. So I can use this as a conversion ratio in my later steps. Again, everything after the known must be something that's true in order to turn it into a conversion ratio. All right, so let's think about what goes next to grams. All right, take a look at this and pause the video and think about what should go next to grams and what should go next to moles. All right, so I can see right here on top next to grams, we're going to go ahead and put this number, which is exactly what we did earlier, 159.69. All right, and on the let's see if I can move this a little bit more. And then on the bottom, what goes next to moles? Well, next to moles, I have a blank in my molar mass, which means that's just 1. All right, so at this point, we have all of our, oh, let me go ahead and talk about units here. So again, we got rid of moles of iron oxide. I am now at grams of iron oxide. So think to yourself, is that what I should be solving for based on the question that says how many? Yeah, absolutely. That's exactly what I'm supposed to be solving for. So let's go ahead and fill these in. So let me grab a different color here. So I've got 90 times 1 times 2 times 159.69 on the top. Down here I've got 1 times 55.85 times 4 times 1. All right, so again, we need to first solve for what's on top, and then solve for what's on bottom, and then do the top divided by the bottom. So go ahead, pause the video, and think about, grab a calculator and think about what should I be plugging in on top. Do 90 times 1 times 2 times 159.69. All right, so taking a look here, if I do that, I should be getting 28,744.2 on the top. Now let's go ahead and do the bottom here. All right, so again, solve for what's on the bottom here, which is going to go ahead and be 1 times 55.85 times 4 times 1. Pause the video and try that one out. All right, so on the bottom, you should have gotten 223.4. All right, and now all we need to do is we have a fraction here, but remember that fractions are just division in disguise. All right, so we're going to go ahead and do the top number first, divided by the bottom number next. Again, in your calculator, it's always the top number first. So 287.44.2, that's on top, divided by 223.4, that's the number on the bottom, the denominator. Pause the video, continue playing once you have an answer. All right, so taking a look here, I have that the grams that I have are 128.666 here. So taking a look here, the 6 right here is actually going to be a big number after this second digit right here. And so if this is a big number, the second digit actually needs to get rounded up. All right, so we're going to go ahead and fill that in. Oops, sorry. Here we go. So this would be 6-7 instead of 6-6 because it needs to be rounded up. All right, so that should be your final answer. Hopefully that's what you got. If you did not, make sure you go back and try again. Okay, so taking a look here, this should be your answer for number 5. So in the first blank, you're going to go ahead and fill in the number 128.67, and in the second blank, you're going to go ahead and fill in the units, which should be G space Fe2 O3. Keep in mind that this right here is an O and not a 0. It is an O, Fe2O3 for iron oxide. Go ahead, pause the video and continue playing when you're ready to move on. All right, so let's go ahead and try this last problem. This last problem you need to be able to finish on your own. So make sure you understand how to do 3-step stoichiometry, especially since you will need to be able to do this on your exam all by yourself. So how many grams of oxygen are needed to produce 45 grams of water? Pause the video and think to yourself, what is your known? What are we starting with? Well, I should know that my known is always the thing I have a number for. So taking a look here, I have a number 45, and the units would be grams of water, right? So I'm going to go ahead and make my starting side H2O, water. And again, we're starting off with grams, which would be the mass. Now think to yourself, what am I ending with? Well, what you're ending with is how many grams of oxygen. That is a new chemical, so I'm going to label my new side as O2 for oxygen. And again, we are solving for grams here, so we should be ending with mass. Now think to yourself, what are the middle steps? Well, the middle steps here are first we need to get to moles of the same chemical, H2O, and then we can convert moles to moles to our new chemical, oxygen, using our magic mole ratio from our chemical equation. So let's go ahead and start this off. Again, we're starting off right here with our grams of H2O. So let's fill that in. I had 45 grams of H2O in my problem. And remember that I want to turn this into a fraction, so I should put it over. Let's put it over 1. All right, now I want to get rid of grams of H2O, so think about in the next step, where should it go to get rid of it? On the opposite side. Yeah, that would be the bottom, so grams of H2O goes on the bottom here. And now I can convert to new units, but it has to be the same chemical. Remember, I can't change to a new chemical until I'm in moles. So taking a look here at step number 2, what should go on top? All right, so on top, we're going to be solving for moles of the same chemical, which should be moles of H2O. Now, we have our units here, right? But we need to figure out what numbers go in here. So again, let's take a look at everything that is standardized or true in our problem. So we have a molar mass of oxygen, that's always true. We have a molar mass of water, that's always true. And we have a balanced chemical equation, that's always true. Of those 3 things, which of those 3 things includes both moles and grams, specifically for H2O? Pause the video, think about it. So taking a look here, right, we have a molar mass that includes grams and moles for oxygen, but we also have a molar mass with grams and moles for water, and this is water, so we're going to use the second one here. We're not going to use the balanced chemical equation. That only has moles. It has no mass in it, so that's not useful to us yet. So taking a look down here, think to yourself, what should I fill in next to moles? What should I fill in next to grams? Well, next to moles right here, I have a blank, and blanks mean 1. And next to grams right here, I have 18.02, so that's what I should fill in on the bottom here, next to grams. Again, if the units were flipped, then I would flip those numbers as well. The numbers should go next to their units that you see here in the molar mass. All right, so let's get rid of this one because we have taken care of that. Cool. So I've gotten rid of grams of H2O. Let's go ahead and take a look. Now we're at moles of H2O. Yay, I'm at moles. Now I can use the magic mole ratio to go moles to moles. So think to yourself, I now am going from moles, right? That's going to go on the bottom because I'm getting rid of H2O, moles of H2O, to my new chemical. What is the new chemical? Again, we're going moles to moles, so it should be moles, but think about what's that new chemical. Yeah, so over here we have a new chemical, O2, so moles of oxygen are now on top. Now again, anything after the start must be standardized or always true when we do conversion ratios. So think to yourself, which of our two remaining things has both oxygen and water in it and is just moles, no grams? Well, we have a molar mass that includes grams, so that's definitely not going to work. It also doesn't work because it's only oxygen. It does not have water involved. So the only thing that works here is moles to moles. We always use our balanced chemical equation. So taking a look here, how many moles of O2 are in the equation? That's what's going to go on top. How many moles of H2O are in the equation? That's what's going to go on bottom. Remember, that comes from these big coefficients in front. Pause the video, think to yourself, what should this one be? Well, next to oxygen, I have a blank in front, and blanks mean 1. And next to H2O, I have a big number 2 in front, so there are 2 big moles in our chemical equation here. So that's where I get that from. Again, at this point, I've gotten rid of moles of H2O. I just have moles of O2 on the top. Is that what I'm solving for? No, again, the question right here is how many grams of oxygen. I'm only at moles of oxygen. But again, now that I'm in my new chemical, I can just use molar mass to finally move to my last part right here, which is to look at the mass of it, right? So I'm going to get rid of moles of O2 by putting it on the bottom. And I want to solve for grams of O2 now by putting that on the top. So grams of O2 goes on the top here. And let's go ahead and figure out what should I be filling in for this. Again, think about what is the standardized, always true statement that we have that includes grams and moles, specifically for oxygen. Well, there's only one thing left, so this should be pretty obvious, all right? So we know that we're going to use the molar mass of oxygen. That's something that's always true. Think about what goes on top next to grams and what goes on bottom next to moles. Well, in our molar mass right here, we have next to grams the number 32, so that should go on top. And next to moles, we again have a blank. Blanks just mean 1. It's, remember, per 1 mole, so that goes on the bottom. All right, so we have all of our numbers here. Let's go ahead and look at our units. We get rid of moles of O2. I'm left with grams of O2. And that should make perfect sense because that's exactly what I should be solving for down here. Now that being said, all we need to go ahead and do is figure out the numbers. Again, the rest of this you need to be able to do on your own. And again, on the exam, you'll need to be able to do all of this on your own. So make sure you really understand this process. So let me grab a different color here. On top, I've got 45 times 1 times 1 times 32. On the bottom, I've got 1 times 18.02 times 2 times 1. Remember, first you need to solve for what's on top. All right, so solve here. Actually, let me change these all to different colors just so we can make it really obvious. There we go. We'll just make this really obvious that these are different parts of the equation. There we go. And here we go. Okay, so first we need to solve for what's on top. Again, 45 times 1 times 32. Stick that on top. And then on the bottom, we need to go ahead and do 1 times 18.2 times 2 times 1. So that goes on the bottom. Once you have your top number and your bottom number, you can then go ahead and divide the top by the bottom, right? So we can then go ahead and do the top number first in the calculator divided by the bottom number denominator second in the calculator. And that should give us our answer. So let's go ahead and take a look here. So make sure that you solve that. Again, solve for the top, solve for the bottom, then do top divided by the bottom. You should have 2 decimal places. Otherwise, the computer will mark it wrong. So, right, point blank blank. Make sure you have 2 decimal places there for your number. And then for your units here again should be G space O2. Again, this is an O for oxygen. It is not a 0. If you put in a 0, the computer will mark it wrong. So G space O2, capital O2. This is number 6. Go ahead and solve this and pause the video and continue playing when you're ready. All right, so at this point we have been able to identify the correct steps of a stoichiometry problem using our mole roadmap, and we've been able to complete 3-step stoich problems. So go ahead and think to yourself, how would you rate your understanding of today's objectives? Remember that if you are very confused or still need some help, then you should be reaching out to Mr. Bangle for tutoring. Okay. Remember that I am out on maternity leave, so I cannot help you. And with subs, with the new sub and everything, they are not as familiar with the content. So Mr. Bangle is definitely your best bet here, just because he has been with us the entire time. So make sure that you reach out to him if you need help on projects, exams, or understanding any of these concepts. If you're feeling pretty good or awesome, that's great. Hopefully you will be ready for your last exam. All right, make sure you submit your 4 notes. Again, you should be getting a 80% or higher on them, assuming that you're following along, assuming that you're working hard with us. Thanks so much, and I will see you later.